Hey y'all, welcome back to another Algebra 2 video. We're going to look at graphing quadratic inequalities. So we've talked about graphing inequalities before this year when we just had one variable, but these are going to be two variables and they're going to be quadratics. So we already know from our previous lessons that a quadratic formula, when graphed, creates a U-shaped graph known as a parabola. So that's what we're going to be doing today. And now with the inequalities, instead of it just being that parabola, we have to do the shading to show if we want all of the points on the line and below it, on the line and above it, or just above or below. And it all depends on if it's greater than or equal to, or less than or equal to, or if it's just greater than or less than. So let's get started looking at this. I just have two quick problems, and then I'm going to give you some practice problems. Again, I want to reiterate the fact that there's no need to cheat on these assignments. There's no need to look at other people's work. Number one, I am here to help you if you need it. Number two, the point of this isn't to get a grade. The point of the practice is to learn how to do these problems. So make sure that you are doing your own work. I don't care if you compare notes or if you ask each other for help or just kind of discuss through, hey, I got this. What did you get? No, I got something else. Well, let's figure out who's right and who's wrong. That's fine. That's one thing. But to just give each other the answers and not to be practicing this or learning how to do it is totally something different, and that is not acceptable, even if you are doing your work from home. So please be sure that you are doing your own work. And if you need help, ask me. I want to help you. Shoot me an email and we can join virtually and I can guide you through some of these. Okay, so we're going to look at this first problem here. I have y is greater than, might help if I use my marker, y is less than or equal to x squared minus 2x plus 8. Okay, so we want to graph this. Well, if you think back to if it was just an equal sign, what we would do, if you recall, we would find the vertex, because the vertex is either the highest point or the lowest point on my parabola, and it's where the axis of symmetry runs right down the middle of it, so we can reflect points across. So the way that we find the vertex is by first finding the x-coordinate, and the formula for finding that is negative b divided by 2 times a. So my b value here is already a negative. So a double negative makes it a positive 2 over 2 times my a value, which is the understood 1 here. 2 over 2 is 1. Now I know the x-coordinate. So to find the y-coordinate, we're going to plug that x value in. 1 squared minus 2 times 1 plus 8. So 1 squared is 1. Negative 2 times 1 is negative 2 plus 8. So negative 1 plus 8 is 7. So my vertex is 1, comma 7. When x was 1, we got a corresponding y value of 7. The other point that I know is this constant tells me where my line crosses the y-axis. It's the y-intercept. So I have this 1, 7, and 0, 8. So I'm going to come up here and graph them on this top graph here. So I go over 1, up 1, 2, 3, 4, 5, 6, 7, and put my point. And I'm going to go ahead and put in my axis of symmetry. It's important to realize that the line that goes right through this cuts it into two equal pieces. So this is my axis of symmetry that I'm putting in right here. Good to label it if you're writing on a piece of paper, which I will give you a hard copy in class so you don't have to try to do this on here. Okay, so now we're going to plot the y-intercept. The y-intercept is 0, 8. So I go over 0, up 1, 2, 3, 4, 5, 6, 7, 8, and put a point. Now, the whole reason that I put this axis of symmetry through here is so that I could reflect that point across. So I have a point here, and now we can draw a parabola. And it's always good to check to see, okay, this is a happy face parabola, so that tells me my a value should be positive, and it is. Okay, now I've got to look at this. I already drew my line on my parabola, but I have to decide, should it be a dashed line or a solid line? That means, do I want to include the points on this parabola or not include them? Well, it says I want the y values less than or equal to x squared minus 2x plus 1. So since it's equal to, we're including the points on the line. Now, I always kind of focus in on the Y-intercept, and I think, okay, this says I'm looking for Y values that are less than that. So all the values that are less than this point fall below it. So that tells me that I'm going to be shading all of this area out here. So all of these ordered pairs are ordered pairs that if I plug them into that quadratic inequality, they would make true mathematical statements. So the only part that's not shaded is this part right here inside of my parabola. Okay, so that being said, maybe what I said didn't really make sense to you. So what you can do is you can pick out a point, let's say 0, 0, and plug it in and see if it makes a true statement. If I plug in 0, 0, it is a true mathematical statement. If I plug in any of these up here, it's not true, so that's why this isn't shaded. So let me show you what I mean. Plugging in 0, 0. Is 0 less than or equal to 0, my x-coordinate is 0, 0 squared, minus 2 times 0 plus 8. So is 0 less than or equal to 8? Yes, it is. So that is why I shaded the part that includes this point 0, 0. Okay, the next parabola that I want to look at, or the next quadratic equation that I would like to graph, let me delete some of this here. So we have more room, maybe. Okay, is y is greater than negative 5x squared plus 10x. Y is greater than negative 5x squared plus 10x. Now, I encourage you to pause the video and in a notebook, try to figure this out. I'm going to go ahead and put plus 0 so that we know what our y-intercept is. But we're going to start by finding the vertex, negative b divided by 2 times my a value. So we end up with negative 10 over negative 10, which is a positive 1. So we found the x-coordinate of our vertex. Now we need to find the y-coordinate. Negative 5 times 1 squared plus 10 times 1 plus 0. So just this 1 is squared. We got to follow order of operations. Take care of my exponents first. So 1 squared is 1. 1 times negative 5 is negative 5. Plus 10 gives me a positive 5. Plus 0 gives me a positive 5. So when x is 1, y is 5. We have just found our vertex. So we can go up here on a graph. I'm just going to do this bottom one, and I'm going to plot over 1, up 1, 2, 3, 4, 5. Plot my vertex. Now, this is a negative parabola, so we know that it should be a frowny face. So this is my maximum value, and we'll go ahead and put my axis of symmetry through here. And we also know this point, 0, 0. So what we can do is reflect it across the axis of symmetry, and now we have our parabola. Now, notice I'm making it a dashed line. Why? Because it's not equal to. We don't want to include the points on our, I said line, but on our parabola, on our graph. We don't want to include these. So now I'm going to pick a point. I can't use 0, 0 this time because it's on here, but I could use, let's just negative 2, 1, 2, 3, 4, 5. Clearly that is not on my line here. So negative 2, comma 5. These are the coordinates of the point that I want to use to see if I shade this out here or if I shade what's inside my parabola. So plugging in 5, we want to know, is 5 greater than negative 5 times negative 2 squared plus 10 times negative 2? Now be very, very careful when you do this. If you just type negative 2 squared in the calculator with no parentheses, it tells you it's a negative 4. But we know that we're squaring this entire negative 2. So negative 2 times negative 2 is a positive 4. 4 times negative 5 is negative 20. Negative 20 minus 20 again is negative 40. Is 5 greater than negative 40? Yes, it is. So we know we want to shade the side of the line that or the side of the parabola, I guess, the part of the graph that includes that point, since that point was true. We do not want to shade inside the parabola. We just want to shade all around it out here. So what that means is all of these ordered pairs outside of this could be plugged into our inequality, and they would be true mathematical statements. So that is all I have. I'm going to post this assignment. If you have any questions, please feel free to reach out to me. Let me know. Again, I want to see your work. I want to see your practice. What can you do?